Might not translate as well, but let's see. What do you prefer? Yes, no, separate or mix or? Okay. Oh. Yeah. Maybe you go first because you're not the first. Yes. So Vijay sits here. Or should we invite?
So I'm the transition. It's a
Yeah, it sounds like
most AI to least AI.
I'm halfway through. You have it. I'm halfway. Well, I can stand there maybe.
You know, it gets one mic. So they can shout. Yeah.
Yes.
How we can move that shape?
It's just a bunch of paper.
More strong, weak sauce.
That AI solve it. Yeah.
Why is it so? I think so.
Yeah, I think so. Hello, everyone. Welcome to the ASPLOS debate. Please come in and take a seat. We're going to start immediately. All right. So the topic for the debate at this year's ASPLOS. Can I get everyone's attention, please? Thank you. Closer to the mic. Is that better?
Yeah.
There we go. All right. Thank you, everyone. So welcome to the debate. We have an esteemed set of panelists who will introduce themselves in a second. And our debate question for this evening is going to be, should everyone work on ML and AI? And obviously we had to have a picture drawn by AI to illustrate this. So we do. Yeah, I'm Joe Divietti from Penn.
I am Paula Das from UT Austin. So thanks to all the panelists for joining us. And I would let them speak about themselves and their stance on this topic, and then we'll go on from there. And the format of the debate is each of them will get some time to speak. And after that, they'll have some discussion. And after that, we'll open the floor to the audience to ask questions. So we can keep it more exciting if you have more questions. Okay.
Okay, this is, yeah, maybe we'll introduce them later. Yeah, no, we'll go through that. So,
Hello.
okay, so, yeah, do you want to do the structure? Okay, great.
So I would appreciate if you all go to that barcode and share your thoughts. We want to see how this debate influences your thought at the end of the session.
Okay, so let's see where we stand initially.
Yeah. Okay. Yes, so they have a harder job.
Okay, team, yes, you have your work cut out for you.
Okay, so which one's A, which one's B? Hard to say.
Yeah, okay, so Charith, you're up. You want to introduce yourself briefly and
Yeah.
fire away?
So I'm Charith Mendis. I'm an assistant professor at UIUC. And so I like precision in things. So what does work on ML or AI even mean, right? So is it that if you are working on systems for ML, does it count? If you are doing formal methods work on ML, does it count? And if you are evaluating your techniques on an ML workload, is it also being categorized as work on ML? And then, of course, if you're using ML for systems optimization and systems for building new architectures, does it count? So you need to ask these questions to be more precise, right? And also, another thing I want to do is like, if you are handling multiple projects, is it sufficient to work on one project related to ML to be counted as you are working on ML? Or is it necessary that all your projects need to be related to ML? So these questions need to be answered in order to be precise, right? So if, in my opinion, if is it sufficient to work on one project related to ML, I think most people may have some project either working on ML or evaluating on a workload. So then the answer is yes. But if you want to work on all projects related to ML, then the answer is going to be no, even for me, right? So I think it's good to define the problems, and it will set the stage for the next speaker. Yeah.
Oh, yeah.
I want to read from the notes so it's faster because I have more slides. I hope it's okay.
Use an AI.
Yes. Okay. So, okay, let's start. My name is Amir. I'm from Google DeepMind. I'm a researcher. 2 points first. I apologize. I have to leave like sharp after the panel. I have to fly to catch, and sorry, I'm missing the discussion afterwards. And the other thing is, of course, whatever I say here does not reflect the views of my employer. Okay, let's get to this. Yes, of course. Why are we asking this question? This is obvious. Okay, but let's put jokes aside. I wanted to start this voting, but they already did the voting, so we're gonna skip this. Machine learning has been disruptive, mostly in a good ways, of course, and it is transformative and economic incentive for almost every aspect of human lives. AI for science, technology, drug discovery, a vaccine, boosting the performance efficiency, increasing the productivity of software engineers. Not only that, but also literally saving human lives through like flood forecasting and improving the quality of life for everyone. So let me actually play this if I can.
AI, generative AI, generative AI, generative AI, AI is AI, 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 AI. It uses AI to bring AI, 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 AI.
I hope you're convinced now. Perfect. Okay. In fact, a Google mission is, but that was a joke, but the Google mission is literally committed to significantly improving the lives of as many people as possible. And I think machine learning is one of the most productive way to achieve this goal for the humanity. And okay, this one. Generative, no. AI is not working. Okay. In fact, it's not only that, but there is also exponential increase in the market share of Gen AI. As you can see in this study, it's a huge growth over the next few years. I like what Andrew said about the ML is the new electricity, and I want to rephrase it in a way that is better. It's a better context for our community. I think ML is the new transistor, and I would and I think we should invest in ML research the way that if we invested for transistor and how we leverage the potential of transistor. Okay, to conclude, not only there is economic interest to do research and work in machine learning, but also there are a lot of interesting and challenging problems that that we as a community we should get together and work on it. This is interesting. Why not work on it? And because of this reason, I believe that ML research is bullish, at least for the foreseeable future. Thank you so much. Yeah.
Hey folks, I'm Vijay Janapa from Harvard. I'm a faculty member, but I'm also very deeply invested with industry activities. So I'm one of the co-founders for ML Commons, which is a nonprofit organization focused on enabling machine learning for everyone at scale. Now, the way I'm going to talk about, why I think everybody should be looking at ML is by going back fundamentally to sort of, what ASPLOS' mission statement really is if you go to the website. It's a premier academic forum focused on multidisciplinary computer systems research that spans hardware, software, and their interactions. It involves computer architecture, programming languages, operating systems, as well as networking and storage and so forth. Now, if you kind of take a step back and you look at the evolution over the last 42 years, even though there are 29 instances of ASPLOS, for those of you who are not familiar, ASPLOS used to be every other year and so forth, but things have changed. Over these many years, there's been an incredible amount of innovation in the traditional computing system stack. Now, this is shout out for Emery Berger and Ben Zorn, who recently wrote a Cigarch blog post about this, talking about how traditionally when we've kind of thought about systems, we've kind of built it up in this way. We had a hardware, we came up with the ISA, we have OS, then we have ABIs and so forth, all the way up to the APIs. Then comes AI, right? Which is a fundamentally disruptive sort of technology when you actually look at how the system stack really needs to be thought about. When it looks at the system stack, you're going to have to rethink systematically all the way from the bottom up about what it really means to build a new generation of computers. And that is really an opportunity for us. Again, big shout out for Emery Berger and Ben Zorn, who recently put this together. I love giving people a shout out. Andrej Karpathy, a big visionary in AI systems, generally speaking. He was one of the guys behind Autopilot at Tesla. He had this vision about the LLM operating system. Basically, if you're going to look at it, he talks about the LLM as being sort of a new opportunity where you kind of look at, how many cores you have, right, which is the batch size, how many tokens per second you're generating, effectively the new clock rate, and so forth. So you can effectively think about building the next generation of systems thinking about the LLM operating system, right? So it opens up the whole new realm. Then wide array of different challenges that Amir and I have actually talked about in the past. But effectively, what I'm trying to come down to is if you take that LLM OS computer as a new generation thing, it opens up a whole new space for what ASPLOS has stood for the past 40-something years, right? And so I'm very much looking forward for what the next generation of ASPLOS is going to really look like when we really take ML from a systems perspective very seriously.
Okay, but we can switch it from here. Yeah.
Thank you, Torrellas. Hi, I'm Moin Qureshi. Moin Qureshi from Georgia Tech. I decided to talk about neither AI nor ML. I'm going to talk about finance. I'm a tenured professor. I can talk about anything, right? It's great that I'm in San Diego. I love conferences in San Diego. Last time I was at an architecture conference in San Diego, the world was locked down for 3 years. When life gives you lemons, you make lemonade. What did I do during the pandemic? I'm like, for fun, let's just take a course on investment. Why not? And so I learned about modern portfolio theory, and the goal is to maximize the return under a given amount of risk. And there are two key takeaways from this course. Past performance is not an indicator of future performance. Second, diversify, 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 diversify. Everybody knows these principles, and everybody quickly forgets them. That's a story that happens again and again. So now if you look at investment, there's an exciting thing happening. There's a hardware company, I shall not name it. The stock price has increased by 200x in the last 10 years, right? I plotted this data, 200x. It's very tempting to have a greedy approach where you take all of your money and invest in this highest performing stock. I would advise against it, right? We have been here before. The internet revolution, everybody should invest in Cisco, 900x in 10 years. Right? It happens, right? So the principles, this is embarrassing. Which AI did this? Okay, so the principles of moderation and diversification are very useful. It doesn't matter whether you're investing money or you're diversifying your portfolio, research portfolio. It's okay about the topic, ML versus non-ML, both. It's just a question about how much. It's up to the individual. They should really do whatever they think will have the most impact. One caveat, if this community focuses on one problem for a very long time, the actual skills to do hard problems that are very important, those will evaporate, right? That's my only concern. So as we are investing our time, diversify. And the main takeaway from this talk, if you have not studied the basics of finance, please do. Your future self will thank me. Thank you.
Right, so my name is Tamar Eilam. I'm a chief scientist of sustainable computing in IBM Research, and I'm not going to talk with you about finance. So How do we make decisions about what to study? If we follow the paradigm of rational thinking, then the best practice includes balancing potential value, risk, and effort. Viewed from this point of view, AI's potential value is enormous. It is proved to be a very powerful tool that can lead to scientific breakthroughs in areas that are critical to human existence and well-being, such as climate change. For instance, AI can be used to accelerate the scientific discovery of new materials for carbon sequestration, analyze satellite images, and also find new materials that can help us with that are less carbon intense for manufacturing of semiconductor devices. However, AI has serious limitations. The one that personally concerned me is energy consumption that is associated also carbon, which is used for manufacturing. So it is projected that by 2026, AI is going to consume energy that is equivalent to a small country such as Japan. So this is really sort of not sustainable. So we need to work on technology to improve the energy efficiency of AI, right? Now you may call it working on AI, but in my opinion, that is just working on different disciplines informed by requirements that are coming from the AI use case. More importantly, what we need to do is bring together multiple disciplines: theory for algorithms innovation, systems research for new systems architecture, and material science for new materials. Okay, and you can call it AI research if you want, but the most important thing is to nurture these disciplines of thought. The other point I like to make, finally, is that any community, such as ASPLOS, is made of individuals. These individuals have passion and curiosity that is unique to them. And this is essentially what differentiates us from the machine. So my point is, let the people follow their passion, because this is how we're going to get to great innovation, new computational models, and so on. So my answer to this question is no, not just AI.
Hello, my name is Josep Torrellas. I'm a professor at Illinois. I won't be able to keep up with Mohit here, Moin. So should everybody work on machine learning and AI? No. So the most important thing is an efficiency argument. It's very hard to make an impact. Companies such as Google, as we saw this morning, and many other companies are laser focused on ML and AI, and they have the resources. How can most of us compete against them? We cannot work on small incremental problems, because if we do, small incremental problems in ML and AI, because if we do, we're going to be scooped. We're working on something, and then Google comes along and they're able to do it 3 orders of magnitude faster and better. Let's face it, most of us are doing crappy research. I should be careful. I do crappy research, right? Modifying some aspect of a neural network to make it kind of a 5% faster, or modifying a layer or something. This is not going to have an impact. So if you really, really want to have an impact in AI, you need to have a significant group of students, and you need to pick your problems very carefully, because by the time you're ready to publish it, probably Microsoft or Google are past that point. The second reason why we should not all work on AI is that the progress in IT, and indeed in machine learning and AI, depends on many, many other areas, progress in other areas, and that includes energy efficiency, as Tamar has said, security, systems work. There's so many things that we need to do to be able to enable the revolution of AI. So that's it. Thank you.
By the way, there is a gradient descent here. Most AI. At this point, rather than we talking between each other, I think it'd be good if somebody wants to ask something, go ahead, right? And if we need to chat, we'll chat anyways.
There are mics around.
See, the thing with senior people, they like to talk.
John Demi, Microsoft. I have yet to hear from the S team why literally everyone in this room and in the research community in general should be working on AI exclusively or in part.
Hello, this is why I wanted to define what work on AI mean, right? So there is a necessary and a sufficient condition, I feel like, right? Like, is it necessary that all your projects need to be on AI? Or is it sufficient that one of your projects is going to be on AI, right? Yeah, I'm okay with that. Like, so what I'm saying is like, yeah, so wait. Like, so let's look at like, let's show of hands, right? If like, so this is for like people who have multiple projects. Who does not evaluate on even one AI workload, right? Like it can be one CNN layer. Okay, there are few, only a very few that do not evaluate on one AI workload, right? Yeah, sure. So that's why I said like the problem is ill-defined, right? Like, so should work on AI, like you need to define it properly, right? Like, so that's the whole part of the debate. We have to define what that means, right? So, and sometimes you are working on formal methods for AI. Does that count? I mean, formal methods, people are like almost really the other spectrum of AI. Does that count? I don't know. So that's why we have in this debate. And if that counts, then like there are a lot of people who are working on AI. Should literally everybody work on? So that is up for debate. Yeah. Yeah, I mean, like, that's why we have to define it properly. Like, I don't like the definition that much.
Let me just expand a little bit on this. When we talk about what is working on AI, you can work on, you can use AI for a particular application, like how do I use AI in order to find new materials or analyze satellite images. You can work on AI on the model level, like inventing new neural network architecture. You can work on AI optimization in the platform level or on a new system architecture for AI. Or you can use AI to help you with whatever you do. Like I'm writing an article and I'm using AI to help me, whatever I'm coding, and I'm using AI in order to code better, right? So we need to define what we mean by that. And I think what is more important is what disciplines do you need? So for example, I'm listening to all of these talks here today, and I just attended the 1D and 2D on AI, on the inference optimization and quantization. And the disciplines that are being used are algorithmic disciplines, are graph theory, and so on. So this is also important to ask, even if I'm working on AI, what kind of disciplines do I need to have? What kind of skills do I need to have in order to actually innovate?
So again, I'd like to sort of give a more philosophical view of why and which problem we should work on. There are only 3 good reasons to work on a problem. First, it gives you joy. Don't care about the world, don't care about anybody else. Gives you joy, do it. Whether it's AI, non-AI, doesn't matter. Second, the world needs it. Do it because it will have an impact. as a researcher, that's personally very important to me. Third, do it because it'll give you money, right? Those are basically the only three reasons to work on any problem, whether it's AI, non-AI, it really doesn't matter, right? If you find joy in something that is not AI, if you feel that that work will have an impact on systems, people will use it, it will make the world a better place, do it. It doesn't have to be AI. I agree with Amir that AI is a very big opportunity, new opportunity to affect human lives, but it's not the only opportunity. There are enough opportunities, reduce power, reduce carbon footprint, make systems scalable, better performing. All of these are incredible problems. So rather than having this narrow view that AI is the only way to make progress, do it for the other reasons too.
Question? Okay, I'm audible, right? Okay, let's say tomorrow ML AI is wildly successful, right? I think the more this panel should have been reworded as should everyone work ? And stop there, right? Because I mean, nothing else there for us to do, right?
That's the dream.
Okay. So Hadi Esmailzadeh, UC San Diego. I think, first of all, I'll say it out loud. The answer to this question is a resounding no from my perspective. But I'm not here to make a statement. I want to ask a very concrete question. I mean, this entire community for the last 10 years have worked on performance and energy efficiency, regardless of AI or ML. And then we're doing that for AI and ML. So for people who are sitting on the panel, I want to ask, there are lots of young people here. Give us a little bit more threads to hang on to. Be a little bit more specific on what you really think that if a young student who's just starting to, work, what kind of problems you see that are important, instead of just saying performance, energy efficiency, and security. I'm not picking on anybody. I'm just saying that that's not a satisfying answer from my perspective.
So I would say first, I see that most of the students that come want to work on AI and machine learning. And I'm seeing also that the conferences are piling up papers on AI and machine learning. It's harder and harder to get people to write papers on other things and to review many of the topics. I think it's a loss that many students don't know about processor design, they don't know about coherence protocols, all that sorts of things. So I would say the basics, they need to know about the basics. That's the very first thing, right? So you need to take all the courses and then you do AI. So basics is the most important thing,
I mean, I can interpret that as this, we need to go back a little bit in time.
Not quite. So okay. See, I would say that we are at actually a very unique opportunity. For young grad students here, you are at a much, much better place than I was as a grad student in 2002, where the biggest thing was how big is your reorder buffer and what's the frequency, and nothing else mattered, right? Look at technology. Technology is currently at single-digit nanometers, getting smaller and smaller. These devices are not working. DRAM rowhammer is a big problem to a point where the DRAM industry has taken the biggest step in decades. They're going to re-architect arrays and change timex, right? Power is such a big problem that the power consumption of our machines is getting to a point where it's equal to some countries' entire energy consumption. Most of the big problems, including AI, are limited by performance and scalability. This really is a golden age, not just because of AI and ML. There is pressure both from devices, scalability and power, and applications. This is a fantastic place to be in. There are lots of good problems to solve. the kind of problems that the young generation will solve, there's a huge chance of having an impact.
May I interpret that? Repeat how I hear it. Do you mean that we look at AI as just a workload, and then go think about as an opportunity that gives us an ability to go back and re-examine some of the assumptions in the technology side and also in the system design side, and use the excitement that is happening in there to our advantage to advance foundational innovations?
So how okay. Let me quickly mention this, right? As I mentioned, focus investment in one area, continued investment, takes the skills away from other potential areas. If you're looking at a workload that's highly regular, highly parallel for a decade, this community may no longer be able to actually handle workloads that are irregular, that are latency critical, that have tail latency problems, scalability problems. All of those are also important. And that's the reason why I asked the question I asked to Amin this morning.
Let me just add one sentence, which is I totally agree with the two speakers here. I think we're at an inflection point, and that requires new thinking, that requires actually going back to the basics, not just with understanding computer architecture, also with theoretical computer science, with algorithms and complexity, and inventing new computational models, because we're at a point where we can't keep up with the power requirements, right? So going back to the basics, taking a step back and coming up with a lot of new things.
Thank you.
Oh, also just wanted to say we want to hear from Team Yes, because they're the underdogs.
We're taking more of the workload.
So first and foremost, the big thing that I think we got to clarify is AI is really a melting pot of different things, right? It's like the United States, in all honesty. It does not mean that we ignore the foundations of the fundamentals. It builds on the foundations and fundamentals. So yes, we need to understand processor design if we want to build foundation models for chip design, right? It doesn't take anything away. It is just increasing more. Yes, you have to learn more. Yes, that's one, right? And the second thing is sort of recognizing that I already forgot what I was going to say because that point was so getting me riled up in my head. So I'll just stop there.
That's what we learn about memory systems.
Sorry. Here's the idea. For the kids in the room. Sorry, I call all graduate students kids. But think about how often you have an opportunity to invent a fundamentally new way of thinking about a computing system. You get to scrub away everything. That LLM OS that I'm talking about. Think about the new fundamental law of computer performance you could come up with if you go down to the fundamentals and kind of look at how would I design a computer that's fundamentally built around AI. That's an opportunity, a golden opportunity. You should think very carefully whether you want to take that or you don't want to take that.
What if you did that based on blockchain?
I guess so. Hello, yeah, I'm Matt from TUM. I'm a very young grad student, and I'm going to ask a question towards the yes side for load balancing, which is, I think we can all agree that we are at kind of the height of the AI bubble right now. Like there's more resources and more people working on AI than ever before already at this point. And even despite that fact, the story from the few past years of AI has mostly been that of failure. It's been mentioned here, the Tesla autopilot. Well, the Tesla autopilot famously doesn't work anywhere outside of a straight highway in the United States. The Uber self-driving system was completely scrapped after there was a test drive that took 1 mile and ended with the car in flames. One other thing that was mentioned, Google DeepMind published in November last year a paper on material research that was assisted with AI that was soon later derided by experts in the field as not actually being that as innovative as it was touted as, and maybe not worth the effort. And despite all of those things that are happening when we are investing as much into AI as ever before, the yes side would like us to increase that investment and get more people to work on it and invest more money probably into it. And I would just like to ask why, like, is there anything on the horizon that would show that we can turn the tide of the current technologies that we have? Especially since it's impossible to talk about this outside of the context of LLMs, which thus far, I don't know, and the two products that you could call successful are ChatGPT and Copilot, which both, as we know, don't earn any money because it actually takes more money to invoke them than either OpenAI or Microsoft are able to do from this. So if you want more people to work into this, you kind of have to have some hope that this can be, I don't know, fixed. Like, what's the incentive here actually?
Yeah, I think that's a great question. So as you said, right? So maybe AI right now burns a lot, and that's actually an opportunity. Why do you say that's a problem? We have to work on system for AI, right? We have to make it more efficient, which is for one fundamental application that is really important and taking all over the world. And it has a lot of good impact on human life, right? You mentioned a lot of problems, self-driving, many, many different problems. And these are opportunities for all of us as a community to work together and fix it.
Yeah, well, if I can, then I just ask a direct question, which would be, what is the great impact of ChatGPT for humanity currently? Because you're saying that it is there, but what is it?
So, I mean, I'm going to answer the previous question. Like, so if you don't understand something and if you actually don't know what it's capable of, isn't that a very good area to do research on? Like, do you want to do a research on like something that's already matured and you know something about it? I would much rather be in an area where we don't know much about and what's the actual capability of it, right? Like, so that's something I'm more interested in.
Oh, welcome to quantum computing.
Really interesting discussion. Hi, I'm Anish from Georgia Tech. I guess my question is AI self-contained, right? Especially for the people saying yes on the debate. That is, usually we get inspiration for answers from other areas, right? There are algorithms derived or inspired by genomics. In LLM inference, there is concepts of caching and all of that. That's outside the realm of LLM. That comes from basically outside of the realm of LLMs. So is AI so self-contained that if everybody works on it, we would not need inspiration from these other areas because we would not have any, progress on these other research areas?
So that's that's why like there is a broad, it's broadly construed, right? Like, so if you're working for systems for ML, like you should be inspired by previous techniques, right? And if you can use it to actually accelerate ML, isn't that a good thing, right? Like rather than reinventing something with like a fancy technique that requires a lot of wheels, if you can use a simpler technique to accelerate something, that's much better. And I think like that's the goal as well. That's my opinion.
Not to Anish, but the previous question that the person asked, what has ChatGPT done? I would say it's incredible. I don't know how to write Python. One of my biggest problems was how would I make plots? Now I just take the data, I put it in ChatGPT and say, make a plot. It makes a beautiful plot. I put it in. It's making me very productive. Real world impact.
I want to add one more point to that. A lot of people have been saying, oh, there's so many people are working on AI. I'm going to call you BS on that right now. You know how big the world is and how many people actually have access to this technology? Let's get real about this because it's an incredible tool in order to enable equity in the ecosystem, right? People don't talk about it. You can actually use that agent to be able to effectively bring equity in education. That's one of the most important things if you think about it, right? So let's not say everybody's working on AI. We're not. If anything, this is going to create a massive divide, and tools like ChatGPT can help bridge that divide.
Do you democratize AI so that more people can work on it? That's one of the main issues because it's so expensive, right? So we want universities to have access to be able to do meaningful research here.
I really think you have to come over to the yes.
Yes.
Amir, fund us, like, give us more money.
I was just having an enjoyable moment with the access thing. I think the last thing was bridging the digital divide was let's get all the kids laptops. And now the only people who can have their kids not be educated by screens are people who have the sufficient means, right? Like, because I can afford to send my kid to a Waldorf school, I cannot have my kid living on a screen all day. So I don't know if like more technology is really what our kids need. I think actually probably the opposite, but not what I wanted to say. So like, I don't know, 7, 8 years ago, Google had a really great systems research, like system security research group. And at some point, somebody decided we should just move all these people into Google Brain and make them work on AI stuff instead. Some of those people left. And it's not because security is done, but because somebody at Google is like, this is the next hot thing. So, Amir was here and he's talking about, oh, security is so important, blah, blah, blah. I wish people from Google would not give those talks because you're not investing in that. So if we could actually just.
I'm not representing Google by any way.
Okay.
So just let me clear that.
Right. I mean, Google is a cynical money-making machine, right? And that's what this investment, and they want to blow smoke up our ass about like they're committed to saving the world and everything. But at the end of the day, right, like, let's be real. And it's not just Google, but in other industry labs, like in other companies, right? Everybody's like, if it's research, it's machine learning. And we haven't solved our security problems. And this does have societal impacts. And I don't know that anything I say is going to change anything, but I think it is nice to have some sober voices in the room being like, I spent 20 years of my life in Silicon Valley, right? It's maybe it's the blockchain, it's the augmented reality. We're on the ride again. And it's, maybe we could just be like adults. Be like,
I just add something. I think these are all important questions. Like, first of all, I want to reiterate, I'm not representing Google by any way. That's very important. The other thing I wanted to add it in my concluding remarks. I think it is really important. It's not about what, it's about how we do things. And actually, I have it in my slide, right? It is really important to think about the implications of our research, whether it's AI, non-AI, anything else. We have to think about it and make sure that we are ethical, we are responsible, we make sure that there are safety, security, and all this stuff. These are important topics, and we should all think about it for any research. It doesn't matter what we are doing.
So one of you said that AI is the new transistor. Was it you? I think this is so fundamentally wrong. Not to dunk on you.
That's good.
Dunking on the Google person. I spent 10 years at Google. They bought my 30s. Anyway, what I want to say is that transistors, we understand what they do, right? They are digital logic, right? We can build on them. They're basic building blocks. AI is completely not that at all. It's basically magic at this point. We have no idea what it's doing, and we're giving up a lot of our hard-won knowledge, building up from the ground by relying on AI. And I feel so fundamentally disappointed in where things are going. It's magic. I use ChatGPT for cool things and all that, but like, I really want to understand the things at the bottom. And when you're talking about fundamentals, we need to emphasize that. We need to keep doing work like this at the bottom because we are the nonfiction of this whole story. It runs on the hardware and it runs on software, and like we build that.
I don't think we understand people.
So not only Google is poisoning.
No, I understand.
Wait. Let me finish.
Put me in the panel.
The deleterious effects of Google is that they influence what NSF is doing because they go and say, you know, you guys, not only I'm not giving money to the academia to do research, but in addition, you guys should work on AI, right? And then NSF says, oh my gosh, we have to create all these AI centers at the expense of other areas, right? You look at how many centers there exist now, AI centers, right? So it is creating this big thing into academia as well through NSF, through the funding.
I just want to add something. Again, from my personal perspective, I think this is not entirely true. I can give you multiple examples that not Google only, but many companies actually investing in many different areas. Google PhD fellowship, it's not only about AI. Google TPU credits is not only about AI. There are a lot of other investments that it's not only about AI. Sure, maybe a big portion of it, it's about AI. Again, because there are incentives, this is important application, but it's not all about AI.
Team no. I do want to make a comment based on the question that was made. An incredible experience that happens in your PhD journey is the learning of how to establish causality. You see something in your result and going through the process of figuring out why something works or why something doesn't work, right? To me, that was like the biggest joy or the biggest learning of a PhD is to try to go through the process of causality. What I'm afraid, and it's hard to do that in systems, but at least there is a means to do it. What I'm afraid with black boxes is you get into the habit that I tried and I got 79.6%. And could live with it, right? It's very hard to get into sometimes that habit, that procedure, that mentality of establishing causality. Causality helps you build, not just the problem you're solving, the problem you'll solve next year, 5 years from now, 10 years from now, right? Those principles are very important. Things that I learned in my PhD, I still use it. Half of my papers are on some randomization, some sampling. Things that you learn, you build upon. What I'm afraid of some research culture that happens with black boxes is that aspect goes away sometimes.
I think you're asking a very fascinating question because if you look at what's going on now in AI, I think about it as this humongous brain that encodes all of the human knowledge in these neurons that are being activated or not activated, and we don't really understand how it works. But I think this is also what makes it fascinating. I think we're in very, very, very much the beginning. And I share your frustration about not understanding why things work a certain way or a different way. And I also share your frustration. And I know a lot of other researchers are asking the same questions. Where is the scientific method? Where are the scientific principles? And I think they're not defined yet. And I think this is what is also a little bit exciting if we can understand it better. And I hope we can understand it better.
People love saying that we don't understand AI. I think that's an incredible discredit for the amazing people who are working on ML and theory and explainability and so forth, and interpretability and so forth. So let's not knock those people down, people. If you know how to explain the damn thing, then I'd be okay with it. But you don't. So go talk to the domain experts who actually understand this and not pretend that it's completely black box.
Okay, when you need so I'll say when you need a subfield of AI that's called explainable AI, that says something.
I'm saying I work with these people. That's why.
I know. I have a student working in that.
Scratching the surface with AI explainability is fascinating, and we're just scratching the surface.
I 100% agree with her. We are in the very much of the beginning stages, and we will systematically figure things out, right?
It seems that Vijay, when he speaks, it's going to punch somebody. So. It's kind of suspicious. Whenever you speak with a Google person and they say, you know, we have this team that uses machine learning to do the machine learning. right? So we generate these networks and we use machine learning to generate the network. So something fishy here.
Okay.
Okay, folks,
maybe we can
time
get
for
our-
one more poll. Sorry. People who work on machine learning, how many of you know that you can explain things? Explainable machine learning. 1, 2. How many of you think that it's a little bit difficult to understand why some results come out of machine learning? Right?
How many think it's a lot?
Yeah, so final. Good debate, right? So I have you read the book, The Last Days of the Dinosaurs? Good book. Okay. So why that's important is because these dinosaurs, right? They be really big in size, more oxygen, right? Hollow bones, big creatures. Everybody could see them. This is one event, right? That wiped them out. And who survived? The small rodents, right? So what's that one event that you think, right? That could maybe kill the aspirations of 85% of the people here? Do you see that happening in the next 50 or even 80 years? Right? Maybe deep fakes all over the place, right? So do you see this as a threat to AI? I probably just form a proper question, right?
So I have to leave. Sorry. It's not a threat. It's opportunity. Sorry, I have to catch my flight. Bye.
Amir, it was nice to you.
Yeah, I also think it's an opportunity, right? Like if we don't understand something like that, we should spend time investigating to understand it, especially if it's performing well, right? I mean, if it's actually not performing well, then there's another question. But if it's performing well, like then we have to understand why it's doing so, right? Like and maybe we haven't even touched the horizon yet. Like there may be like leaps that will happen in future. Who knows?
Okay, there will be, I know everyone is enjoying the discussion here, but there is a session after this, so we sort of need to wrap up. How about we do the exit poll at this point?
Sorry about that. Okay. It's the same link as last time if you still have the page up. Okay, let's see where we stand.
So there were a majority of the papers were published were related to AI, right? So how does that?
All right. We gotta cut this off. Okay, so Wacky can start. Thank you, esteemed panelists.
Thank you.
Okay. Yeah, thank you for participating. I think you won. The number did increase. That counts. Who said